Hey guys, just before I start this video, I just wanted to say thanks to everybody that subscribed to my channel. I made a like 5-part full stack React app tutorial. I just wanted to say thanks for everybody that enjoyed it. Like I got a lot of positive feedback on it. I thought that was really cool. Like when I wanted to learn how to like use React to make an app, I found I had to research like a bunch of small little things to really figure out what was going on. To be able to wrap it all up in a bow, it was kind of what I was going for, and I think I kind of achieved that. I kind of just did it for fun, but the positive feedback I got, I thought was really cool. So, I thought I'd try it again. So, let me know what you think, and I hope you enjoy the video. Hey guys, my name's Bryce, and today I have a pretty fun tutorial planned. We're going to be looking at how to use the latest version of the Google Maps API, and this is in February 2019, so that's version 3.36, and looking at some interesting ways that it can be used. So, at this point, we're pretty used to seeing Google Maps, or any map in general, like on different web pages, like on like a, that contact page or store locator page of a business's website. So you can do interesting things like that, but I also just wanted to show maybe some more inspiring, interesting ways a map could be used in a website in general. So let's just get into it. I also just wanted to mention that I'm going to have timestamps in the description below, so if you ever you want to skip a certain section, just feel free to look down and click one of those links. So I'm just here on the overview page for the Google Maps JavaScript API. And I just wanted to start by mentioning, I started playing with this a couple of years ago, and there's been some recent changes to how you get started with the API. So I just wanted to talk about that a little bit. So as with most APIs, you need to get an API key before you can start using it. So in the past, you were able to get one of these with your Google account and just get started. But Google has recently changed its policy, and now you have to enable billing on your account before getting a key. I'm just going to show you how to get started if you don't already have a key. So if we scroll down and go to the link where, okay, are you using an API key? So maybe you created one before. If you did, then that's great. But I'm just going to show this as if we haven't started. So no, I don't have one, and get taken to the page to get an API key. So I just wanted to point out also these links at the top, different things that you can do to best protect your API key and just best practices associated with that. I'm not really going to go through that today just because we're only going to be developing on our local host, but there's things there like, you want to restrict, for example, API access to a certain URL if you're developing a map on a particular web page. So you can restrict it to have requests only come from that domain which you have hosted your map. So again, I just wanted to cover mainly this concept of billing. It can freak people out a little bit just because you kind of have to provide your credit card now, and you don't want to run up like a massive bill. So I just wanted to clarify a few of those concepts. You can see this big reminder in red about enabling billing before we can get started with the JavaScript API. So if I just click this link, it's a bit of a dense article, but I'll just kind of summarize it quickly because I think it's important to be kind of upfront about this. And if you are going to be providing your credit card, I don't want anybody to be overcharged. So they summarize it here. This changed over sometime last year in about July. So they kind of summarize just saying it's a pay-as-you-go model, as that's the standard with most cloud services, and the cost is calculated by the way the APIs are combined into this thing called a SKU, and an API may have more than one. So for example, in the maps, like there's like it's kind of divided up into like a places API versus just like the map API itself. And the cost is calculated by the price multiplied by how much you use that SKU. But the good news is that every month you get a $200 credit in US dollars, which if you're Canadian, it might be a bit more than that with the conversion rate. And yeah, so we get that credit every month. So if you keep your use within that limit, then you don't have to worry about being charged, even though your credit card is connected to your billing account. But even still, you want to be careful just about like who is using this. Today we're just going to be developing on our local machine, so it's not like anybody's going to a website and just executing, making map requests like at an unstoppable rate. We know because it's on our local machine, it's within our control, so we don't have to worry about that. So again, just be careful about where you're going to be developing your map, who is going to be paying for this, and just the usage that map is going to be receiving. And I just wanted to take us back to the API key page and look at the FAQs, because I just want to make this abundantly clear. Here we go. How much does it cost to use the Google Maps platform? So again, if you are below that complimentary $200 per month usage, your usage is free, just as it was. So I'll drop a link to this FAQ page, and I will also include, there's a calculator that Google provided to basically estimate what your usage and billing will be, like based on the tier that you picked and what kind of traffic your site may be having. So I'll drop a link in that in the description below, and you can check that out as well, just to figure out what's best for you. So if we go back, we want to go back to the Get API Key page, and we're going to go down and just click this fancy little Get Started button. So here we are. So we have this dialog pop up, and we want to pick which products we want to include. We've got 3 here. The routes is for doing kind of the directions and distance and things like that. But today we're just going to pick the maps and also places, and then we'll click continue. So we're going to create a new project, and we'll name that I don't know, my map, or whatever name that you would like. I'm going to click next. So it's redirecting us to enabling the billing. So I already have a billing account set up because I've done this before, but if you don't, then you're going to want to follow the steps where you'll provide your credit card and that type of information that we mentioned before, and then you'll be able to enable your Maps API. So I'm just going to click Set Account since I've already done this. And there we are. We're ready to start developing, and we have our API key here. So again, just follow those steps, and you will eventually get your API key as well. So I'm going to copy that and paste it somewhere for later. I also just wanted to point out within the Cloud Platform portal here that this is where you can actually restrict where the API can be accessed, as I mentioned before. So that specific websites, web servers, and even apps can be the only ones that can use your API key, just in the case that somebody else grabs a hold of it, and if they made use of it, it would be charged to your billing account, and you wouldn't be too happy with that. So again, the secure credentials, if you go here, you can set that up. Alright, so enough of me rambling about billing. We're ready to get started. So if I switch over to my text editor, I'm just using VS Code, but whatever editor you want to use is fine too. So I've set up just some a basic set of files to get us started. We've got our main index.html page, we got a style sheet, it's blank right now, and also a just main JavaScript script. And I'm also using the live server extension for VS Code, and all that does is just live reload the page in our browser whenever we make a change, so we don't have to manually refresh like 100 times. So I'll start that up, and we can see our page pop up there. I'll just expand that so we can see what's going on both sides. I made the font huge in VS Code. One of my last videos, it was showing up pretty small, so hopefully everybody can see this okay. So nothing crazy going on here. We just have our standard kind of HTML document, and I just included Bootstrap for the hell of it, just for the responsive features, and just to show how you might include other scripts here alongside the Google Maps API script down here. And I just have our style sheet and script attached, obviously, and just some code here basically to get us started. So the first thing we're going to want to do is create a container for our map. So if we go down here, we do div, and we want to give it an ID of map. Then we want to jump over to our style sheet and just add a rule for that. We want to give that map container a height. So we're going to give it a height of 500 pixels. Easy enough. Save that. And now we need to provide our API key to the script tag that I set up down here. And that just starts as $key is equal to this. So I'll copy and paste my key. So lastly, we just need to add another argument to our request URL, and it's going to be the name of the function that we want to be called when the script has been loaded. So we're just going to go here and add callback is equal to create map, and then an ampersand, and then we'll switch over to our script file. And okay, we'll start by creating a variable called map, and then the function create map. And in there, we want to first start by making a variable called options. It'll be a object. The first attribute will be center, which represents, as you probably guessed, the center of our map. So I'm just going to copy and paste that. It's an object that just contains two attributes for the coordinates, which is latitude and longitude. And then we'll also just add another attribute called zoom. And obvious again, it's just how close we are to the ground in the map. So finally, to get our map to render, we just have to call the map constructor, passing in our container that we created earlier, just the div. So if we go map is equal to new Google Maps.map, we pass in the reference to that element. So document get element by ID, and the ID was map. And then we also pass in this options object to configure our map. So if we save that and our page reloads, there we go. We see our map appears. You've embedded a Google Map into a web page for the first time. Congrats. Taking big steps today. But let's just see what kind of options we can use to customize our map. So I'll put a link in the description to just the documentation on like the whole reference of different map options, but I'll just show you a couple that I have written down here off the top of my head. So if we go and we set an attribute of disable default UI, set that to true, we save, it'll reload. We can see that all of our standard controls are now gone. So this might be a choice if you don't want your user kind of leaving the location you've set up in the past. We can get rid of that now. We'll try another one. There's another one called draggable, and set it to false. And this is kind of an obvious one too. Whereas before we would have been able to drag our map and move it around, we can't. So again, maybe it might be a choice for keeping your user in the same sort of spot. And here's another interesting one. We can go and change. If we go to the map type ID. This is going to set the view of the map that we see. So whether we want it to be a road map like it is right now, or if we actually want to see like some satellite images, or maybe a mix of both, we can set the map type ID to be something different. So if we set it to hybrid, for example, and it also works if you can pass in a string, but this is also just like the reference to the actual like the enumerable string option kind of thing. So if we save this, we can see that, oh, it reloads and we have the hybrid view. So it's the combination of the satellite image with the roads. Pretty cool. So let's get rid of that and we'll set it back just to our default map again. So now let's say we want to do something different, like we want to customize the style, as in like the colors and just the appearance of the map. There's a whole host of different style settings, and I'll put a link to that in the description again. I'm not going to go through and explain all of them, but there's a whole convention that needs to be followed, but I'll just copy and paste some in that I found kind of cool looking. Let's put that in there. You can see there's a whole bunch of different JSON objects, so they kind of just pick different element types, and you can do change the appearance of them, like by providing a color or you know, like different opacity, different things like that. And there we go. So when we saved and reloaded, it's, you know, we have a really kind of interesting, funky looking map there. So you have a lot of control. And again, I'll put the link to all those different settings. So once again, I'll just reset it back to our boring default gray map. And now let's take a look at, instead of looking at the controls and styling, we'll look at adding some functionality. So maybe it's something you've already wondered about, but what if we wanted to make our map default to the user's current location? So we can do that using the Geolocation API that's available in most modern browsers. So if the user has location enabled on their device, we can use that information to center our map. So let's set this up. I'm going to start adding a variable at the top called info window. And then we'll initialize that with, info window, with the constructor provided in that Google object. And by the way, like in case this wasn't clear, we have access to these, the Google object and these references because we included the Google Maps API script. It drops those things in there for us. So the first thing we're going to do is we're going to check if navigator.geolocation. So this is checking just within the browser if geolocation is available. So if it is available, we can use this method to get the user's current position. Otherwise, we want to just display an error message. So if we go down here, we'll create a new function called handle location error, and we'll take two different arguments, content and position. And in there, we'll use our info window, calling the set position method, passing in our position, and then also using the set content method, which obviously sets the text of the info window, and then opening the info window on our map, so calling open and passing in our map reference. Great, so we'll call that from our else block if it is the case that the user doesn't have geolocation available in their browser. So just call handle location error, and we'll pass in the message no geolocation available, and then passing the position of just remaining at the center of the map. But if the user does have access to the geolocation API, we'll want to call the get current position method of that navigator. So we'll go in here, navigator.geolocation, get current position, and that takes a callback function to run when the position arrives, and they'll be passed into this parameter p. And there's also a second callback in case there's an error. So if there is an error, we want to once again use our handle location error function that we created, and we'll put in a message of geolocation service failed, and once again defaulting back to the center of the map. But if we do have a position and everything worked out fine, we'll start by making a variable called position, and it'll have two attributes, lat and lang. So we'll fill in these attributes, passing in the chords attribute of that the position that gets passed back from the browser, and then the latitude of that, and also the same thing for the longitude. And the reason that we have to do it this way is just because we need to get our object into the format of a coordinate that Google Maps expects. So we have that, and then finally we're going to set the position of our info window to be this position that we just created, and also set the content, so setting the text of our info window to be your location, and then finally opening the info window on our map. So if we save this and our page reloads, we're going to see now that there we go. If you're in Chrome or another browser, probably a little message will pop up and say it will ask you for if you have permission to provide your location, and there we go. It provided mine. Very cool. So alternatively, we could have also went one step further and used our map object to set the center to be that position, but instead it just biased the viewport of Google Maps to contain the info window in the position that we just put it in. So I'm just going to reset this back to our default map. So moving on, let's say we want to be able to search an address or a place and direct our map to that location. So this is why we enabled that Places API earlier when we were getting our API key. And with that being said, let's switch back over to our main index.html file, and we're going to add the libraries. We're going to add the Places library to our URL. So using the parameter libraries, and it equals places. So we'll save that. Oh, and also in our index.html, we're going to add a new row just above our map. And within that column, we're going to put a text input. And we can see our search bar popped up above our map. And if we switch to our main script file, we're going to initialize that input by, well, first we got to grab the reference to it, so get element by ID search. And then we're going to initialize the search box. So this is again a Google Maps constructor, passing in that input document, or sorry, that input element. So the next thing we want to do is make it so that the search results are biased towards the locations that are already in the map's current viewport, in this case in Toronto and kind of the surrounding GTA. So because unless the user is looking someplace entirely somewhere else, they're probably hoping to find a location in the vicinity of where the map already is. So we just want to first load those locations that are in the immediate vicinity. So we do that by adding a listener for the bounds changed event on the map. So we go map, add listener, bounds changed, passing in a callback function. So within this callback, we want to set the bounds on the search box to the bounds of the map. So go search box, set bounds to our maps bound. Great, so now we want to see the search results on our map, so let's make an array called markers. And now we need to add another listener for the places changed event on our search box. So search box, add listener, places changed, and passing in the callback function. So this callback here will fire when the user selects a prediction from the list. So let's start by storing our places. So we'll go variable called places, and we'll get that from calling get places on our search box. Then if we find that no other places were found, meaning that the array is empty, then we don't want to do any other work with our places. So places.length is equal to 0. Then we just want to return. Otherwise, we'll continue on. So the other thing we'll want to do is clear out any markers that were placed before. And this won't be necessary the first time that we search, but for every time afterwards. So we'll call the for each method on the array, which takes a callback function, passing in that the current marker within that iteration. And on that marker, we're going to call set map null, just getting rid of the map reference within that marker. And then we're also going to reset our markers array back to an empty array. Now we're going to create a bounds object, which is the coordinate boundaries of a map. So we'll make a variable called bounds, and we'll set that to new google.maps lat.lang bounds. And now we're going to iterate over the array of places and add a marker for each, and also adjust the bounds of our map. So if we go to places for each, we'll check if the place has a geometry attribute, meaning it has data to be given a position on the map. And if it doesn't, so if not p.geometry, then we're just going to return because we don't want to do anything with that place. And then next, we'll push a marker to the marker array that we created before, otherwise if it does have a geometry associated with it. So pushing a new Google Maps.marker, which accepts an array of options. And the constructor object will take a few attributes. So it will take the map, it'll take a title, which will give it, from our P object here, we'll give it the title, the name attribute of that place. And then we also pass in a position, so we'll grab that from the geometry object and then the location attribute. Finally, we want to update the bounds of our map to take each place into account. So if the geometry of a place has a viewport attribute, so if P geometry has a viewport, then we want to pass this into the union on our bounds object that we created before. So meaning that if this place has a preferred viewport, we want to set the bounds to a combination of what they are with this new viewport included. That might be a little tricky to understand. I'll include a link to the documentation for that if you want to learn more. And otherwise, if it doesn't have a viewport, then we want to pass in the location to the extend method of our bounds, P geometry location. Then finally, we want to call the fit bounds method on our map object and pass in those bounds to put them into effect. So if we save this and our page reloads, we can try searching for a place. So if I try Art Gallery of Ontario, which is in Toronto, you can see that our map updated and it marked that place for us. That's great. So we added a search box and we can update the map based on our searches. So I'll just reset back to our default map once again. So moving on, let's say we wanted to use our map for a slightly different purpose, like showing information at different locations. We can actually visualize GeoJSON data on our map and customize location markers to display this kind of information. So let's try that out with earthquake data from the US Geological Survey. So to start, let's zoom out of our map and make the center somewhere in the Pacific Ocean. So if we set the latitude to 0 and the longitude to 130 and set the zoom to 2, we'll be zoomed way out. And then we'll also change the map type ID to be terrain. Now we're going to get our GeoJSON data. So this could usually be done in a variety of ways, like via an API or maybe just an async request to a backend. But this time we're just going to attach a JavaScript file that already has already contains some GeoJSON embedded within it. And if you don't know what I'm talking about when I say GeoJSON, if I just show this website here to the side, it's basically just a specification for encoding geographic data, and we can see a basic example here. So there are a variety of object types that you could expect, but they all follow this structure roughly, where you have like a type attribute, a geometry object, and then a properties object. And this properties object is the one that we're interested in since it will contain our data, but more on that soon. So we'll create a script element to attach the JS file that contains our earthquake data. So we do this by creating a variable called script, calling document create element script, and then we're going to set the source attribute of this script to be this URL that I just pasted in. I'll put that in the description below so you can grab that, or otherwise you could grab it from the source code on GitHub. And then just underneath that, we're going to actually attach the script to the head element of our HTML document. So we do that by getting elements by tag name head, and then for the very first one, the only one, we append the child, our script as a child. Alright, now we're going to create a function that returns a JSON object containing the styles for the data point that will be displayed on our map. So we'll call this function getEarthquakeCircle, and we'll pass in the data value as a parameter. And this function will just return a JSON object with all kinds of different style properties, and I'll just paste those in now. The most notable one here just being, so the type of symbol that we're using, so we're just using a circle, and the scale is a formula just applied to our data value. Next, we need to add the GeoJSON to our map, so we'll implement a function that is called in the script that we attached. It passes in the data. So this function is called eqfeed underscore callback, and it'll accept GeoJSON as a parameter. And then within this, we'll just call on our map object and the data attribute, the add GeoJSON method, passing in that GeoJSON parameter. Great, and lastly, we need to set the style for our data points. So back in, you can see it's already starting to pop up. If we go back to our main function, we call map, the data attribute, and set style. We pass in a callback that accepts the feature parameter. And as I mentioned earlier, we need to get the earthquake magnitude data from the properties attribute of our GeoJSON. So if we want to grab this on our feature, we'll store it in a variable called magnitude. On our feature, we call the getProperty method. And the property name is mag. That's the actual, within the JSON data, that's the one that holds the value. And then we're going to return a JSON object which specifies the icon attribute, and we'll call our getEarthquakeCircle function, passing in the magnitude. So if we save this and our map reloads, we can see our data pops up. Awesome. So data visualization is becoming quite popular these days, obviously, and there are tons of scenarios on the web where you could display geographic data in a meaningful way like this, so that's pretty cool. So once again, I'll just reset our map. Alright, so we obviously have a lot of features at our disposal, styling our map, finding places, even visualizing data. But this last demo I just wanted to show you is even more fun. We can actually draw editable and draggable shapes on our maps using coordinates. So I'll start just by setting some basic settings for us again, and going to, let's see, 43642 as the latitude, and negative 79.389 as our longitude, and we'll set the zoom to 16, and we'll set the map type to satellite. So our page reloads, and we can see we find ourselves in the heart of downtown Toronto. And suppose we want to wrap a polygon around the Scotiabank Arena here, and inspect the coordinates that make up that space. So first we need to define an array of coordinates for that polygon, but before we do that, we're going to have to move our latitude and longitude values into variables. So if we create two variables, A and B, we'll just store the values in those variables and replace them in there. Then we can actually, and we're going to need to include another one called diff, which is just going to be creating an offset from our coordinate values. So we'll set this to 0.0033. And then below our options, we can define our array of coordinates. So these coordinates just basically create a box around our center of our map, that our location that we provided. So now we can go and we can create our polygon. So we'll call the polygon constructor, and that'll accept an object with various attributes. So I'll just paste that in, kind of go through them. So again, we pass in our map as a reference. The paths is our polygon coordinates that we just defined. I have some colors defined here, the opacity, and then also adding the draggable and editable attributes. So if we save this and our page reloads, we can see that a polygon appeared, and we can move it around and we can adjust it. Very cool. Now, let's say we want to display or even perhaps store the coordinate data for the polygon. We can do this by attaching events to the polygon path. So first, we're going to create a function called log array, and this is just going to accept array as a parameter, and we're just going to display our vertices for our polygon in the console. So within this, we'll create an array of vertices, and then we're going to use a for loop to loop through the vertices of our polygon. So while I is less than the length, using the get length method, increase the value of I, and then we're just going to push a new vertex to our array, and providing the lat and lang attributes. So we're going to get at the index I and call the lat method, and then the same thing for the longitude. So array get at I and call the longitude method. So these functions are pretty self-explanatory, but they are a little strange. Basically, where I'm getting these, it's following the MVC array structure that the Google Maps API uses. If you want to learn more about that special data structure, there will be a link in the description to the documentation for that. And then lastly, we just want to console.log our vertices. Alright, now all we have left is to run this function when the polygon is being edited. So we do this by calling the Google Maps add listener method, and we'll do that within our main maps function. So google.maps.event add listener, and we're going to be adding it to our polygon's path. So we call polygon, but we call the get path method on our polygon, and then we specify the event that is being like the event being fired. So it's called set at, and that is the event that's fired when you edit one of the polygon vertices. And then we supply a callback function, and within that callback function we will call our log array function that we wrote, passing in the updated path. And then finally, I'm just going to duplicate this listener and also call it for the insert at event. And this is a similar event. It's just this one fires if we add a new vertex to the polygon. There's these little side vertices here. So if I save that, and then we open our console at the bottom, and then I edit the vertices, we can see that it popped up down at the bottom there. So I can expand this and we can see an updated list. And if I edit this again, once again it gets logged with the updated lat lang coordinates. Great. So we can see that the array of vertices is displayed, and this is a simple example, but again, you can imagine applications where you might want the user to be tracing something on the map, and you could listen on these events and use this information elsewhere in your page or maybe even in your web app. So there are also other lines and shapes that can be used, and I will put another link in the description for more details on that. So we've reached the end. This is all I have for today. This has been a small demo of some of the features that the Google Maps API has to offer. I hope you found my explanation of how to get started and implement some of these things useful. If you want to find the code, I'll have the code for all 4 of these examples up on GitHub. And please comment and let me know if there's anything more specific you'd like to see done, and maybe I could make a follow-up video with more demos if that's useful. Thanks a lot. If you've enjoyed this video, please like and subscribe. If you want to learn, I made another tutorial series recently, a few months back, about how to develop a simple full stack React app. So if you've been enjoying the JavaScript code here and you want to go a little bit further with it, there's some interesting development skills you can learn over in that tutorial. So, and again, if there's anything you'd like to see outside of Google Maps or anything else in a future video, please let me know. Take care, everybody.